Find L of 1 minus cos at by t. If you observe the problem, it is in the form of f of t by t model. We know that L of f of t by t equal to integral s to infinity f bar of s into ds. Here our f of t is 1 minus cos at. We are going to find L of f of t, that is our f bar of s, that is equal to L of 1 minus cos at, that is equal to L of 1 minus L of cos at. We know that L of 1 is nothing but 1 by s, and L of cos at is s divided by s square plus a square, that is our f bar of s. So now substituting here, we will get L of 1 minus cos at by t equal to integral s to infinity. Our f bar of s is 1 by s minus s divided by s square plus a square into ds. If you observe the integral, if you differentiate the denominator, we will get the numerator, but for the second integral we have to introduce 1 2 to get that form. Since integral f dash of x divided by f of x into dx equal to log of f of x. To apply this integral formula, I am going to introduce 1 2 in the second integral, that is 2s divided by s square plus a square. Then only if you differentiate the denominator, you are getting the numerator. Now if you integrate, the first integral will become log s minus 1 by 2 into the second integral will become log of s square plus a square, that limit s to infinity. Now I can rewrite the term as log s minus, I will take this off to the power of the term and I can write here as of. Since m into log n can be written as log n power m, using this we have written this step. Using log property, that is log m minus log n can be written as log m by n. We can rewrite that above term as log of s divided by, that of can be written as square root of s square plus a square, the limit s to infinity. We can rewrite the term as log s. From that square root, I am going to take one s square out. So if you take square root of s square, that will become s, then square root of 1 plus a square divided by s square, the limit s to infinity. Here this s and this s will get cancelled. Now if you apply the upper limit, you will get log 1 divided by square root of 1 plus a square by infinity is 0 minus lower limit log of 1 divided by 1 plus a square by s square. Now here it is log 1 minus, if you simplify this term, you will get again the same term as this. Since we know that log 1 is 0, 0 minus log of s divided by square root of s square plus a square. Using that log property, I can write this term as log of s divided by square root of s square plus a square, the whole inverse. If you take the inverse, log of square root of s square plus a square divided by s is the required answer. Find L of 1 minus cos at by t square. So if you observe this problem, your denominator is in the form of t square. L of 1 minus cos at by t whole thing divided by t, I can write. Since L of f of t by t is nothing but integral s to infinity f bar of s into ds. F bar of s is nothing but integral s to infinity L of f of t, we can write. into ds. If you apply this here, we will get integral s to infinity. Our f of t is 1 minus cos at by into ds. Now only we are derived this, so directly I can take, but in your exams we first derive this and we have to continue like this. We know that L of 1 minus cos at by t equal to, we'll get log of square root of s square plus a square divided by s. Applying this here, we will get integral s to infinity log of square root of s square plus a square divided by s into ds. To integrate this, we are going to apply by parts form, that is integral u dv equal to uv minus integral v du. By using highlight form, I'm going to fix u value as log of square root of s square plus a square by s and our dv as ds. To differentiate the term, I can rewrite that u as log of s square plus a square whole power of, I can write, minus log s, since log m by n can be written as log m minus log n. So using logarithmic property, I can write this off in front of the term. So therefore off into log of s square plus a square minus log s. Now if you differentiate, we will get du equal to 1 by 2. Log x differentiation is 1 by x, but it is not in the form of x, it is a function. So differentiate this again with respect to s, we will get 2s plus 0. Here log s differentiation is 1 by s into ds. So now rewrite the term as du equal to, here 2 getting cancelled. You get s divided by s square plus a square minus 1 by s into ds. Here our dv is nothing but ds. To get that v value, integrate both sides, we will get v equal to s. Now we are going to apply in the by parts formula. uv log of square root of s square plus a square by s, u into v value is s. I can apply the limit s to infinity minus integral s to infinity v du. V is s into du is s divided by s square plus a square minus 1 by s into ds. Now we are going to simplify this term as s into log of s square common in the square root. Therefore square root of s square is s into square root of 1 plus a square divided by s square whole thing divided by s to infinity. Here these two are getting cancelled. Here before integrating, we will take LCM, cross multiply this term s square minus s square minus of plus minus a square whole thing divided by s into s square plus a square into ds. This s square is getting cancelled, and here this s and this s will get cancelled. We will get the terms as s into log of square root of 1 plus a square by s square into s to infinity minus integral s to infinity minus of this minus will become plus a square divided by s square plus a square into ds. If you apply the limit infinity into log 1, you will get minus lower limit is s into log of s square plus a square divided by s. Plus if you integrate this term, it is look like 1 by s square plus a square into dx, 1 by a into tan inverse of x by a. Applying that, we will get a square is constant I have taken out, and if you integrate this 1 by a into tan inverse of s by a, limit s to infinity. So here since log 1 is 0, so 0 into anything 0, the first term is 0 here, minus s into log of s square plus a square square root of divided by s. plus here a and 1a will get cancelled. We will get a into, if you apply the upper limit, tan inverse of infinity minus lower limit is tan inverse of s by a. So rewriting this term, we get minus s into log of square root of s square plus a square divided by s plus a into tan inverse of infinity is nothing but pi by 2 minus tan inverse of s by a. Since tan inverse of x plus cot inverse of x equal to pi by 2, which implies we will get cot inverse of x equal to pi by 2 minus tan inverse of x. Applying this, we can write the term as L of 1 minus cos at by t square equal to minus s into log of square root of s square plus a square divided by s plus a into, this can be written as cot inverse of s by a. Rewriting this, we will get our final answer. L of 1 minus cos at by t square equal to a into cot inverse of s by a minus s into log of square root of s square plus a square divided by s is the required answer. Find L of e power minus at minus e power minus bt whole thing divided by t. Here f of t equal to e power minus at minus e power minus bt. Now I am going to find L of f of t, that is f bar of s equal to L of e power minus at minus e power minus bt. We can write this as L of e power minus at minus L of e power minus bt. L of e power minus at can be written as 1 by s plus a. L of e power minus bt can be written as 1 divided by s plus b. That is our f bar of s. L of e power minus at minus e power minus bt whole thing divided by t equal to integral s to infinity f bar of s. The f bar of s is 1 by s plus a minus 1 by s plus b into ds, integral of f dash of x divided by f of x into dx equal to log of f of x. Here if you differentiate the denominator s plus a, you are getting the numerator 1. So therefore the first integral will become log of s plus a minus log of s plus b, limit s to infinity equal to log of s plus a by s plus b. Using logarithmic property, we are written like this. Now to apply the limit infinity in the log, we have to do this procedure. Take s common in your numerator as well as denominator. You will get log of s into 1 plus a by s divided by s into 1 plus b by s. So here we can apply s to infinity. Here ss will get cancelled. If you apply the upper limit, you will get log of 1 plus a by infinity is 0 divided by 1 plus b by infinity is 0 minus log of, we get s plus a divided by s plus b. We can rewrite this as log 1 minus log of s plus a divided by s plus b. Since log 1 is 0, we can write 0 minus log of s plus a divided by s plus b. Using the log property, we can write this minus to the power as like this, log of s plus a divided by s plus b the whole inverse. Now taking inverse, we'll get log of s plus b divided by s plus a is the required answer.